All right, so here we are again on page 70. We're doing, looking at playing with radicals here. Number 7 and 8 do that. So let's take a look at a few from number 7. Let me start with 7a, okay? So 7a root 27 minus 4 root 3 plus root 243 and minus 8 root 81 and finally a little plus 2. Now, I mean, as I'm writing this down, I'm spotting that, if any of these have a perfect square root right off the bat, I mean, you would just not leave it and you'd evaluate it. Like I'm looking at this one here, right? Root 81. Why would I write root 81 when I know that that's just 9, right? Root 81 is just 9. So I'm going to rewrite this as root 27 minus 4 root 3 plus root 243, and then that's a 9, but don't forget it's multiplied by 8, which gives negative 72. Okay, negative 72 plus 2. All right, so now playing with radicals, these, like some of the radicals, like root 3 is actually perfectly simplified, but root 27, again, that's not simplified. Your job is to find a number that has a perfect square root that goes into 27 nicely. And the numbers that have nice square roots are these, right? 1 has a nice square root, 4 has a nice square root, 9, 16, and, how am I generating those? Like 1 squared is 1, 4 squared is 1, 2 squared is 4, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. Is that okay? So I'm looking basically to, you know, I'm trying to find a number, one of these numbers, possibly to go into these, okay? So 27, I noticed that 27, right? 9 goes into 27. So I'm just going to rewrite that 27 as a 9. Whoops, that's a 9 times 3. The root 3 can't do a thing with that. I'll just leave it alone. The 243 now, a little bit of playing around with that, you'll see that the next number here would have been an 81, right? And now 81 does go into 243, right? 81 goes into 243 three times, okay? And then let's just collect those to get me my minus 70, all right? Now, there's a property that if you have a product of two numbers within one big root, you can split that up into two separate roots. Okay, like I can completely, that's identical. Okay, and I mean, I can show you that. Like if I gave you this, right? We know that that's root 36, which is just 6. But if I felt like splitting it up into two separate roots, right, like this, I could, and I'm going to get the same thing. Look, that's 2, and that's 3, which does generate 6. So you can do that. Split into two separate roots is perfectly acceptable, which is what I'm doing here, okay? This one I'm going to leave, just that 4 root 3. This I'm going to rewrite as root 81, right? I'm splitting this up into two separate roots, and I'm rewriting my 70. This gives me, right, and root 9 is just 3. So here you are at 3 root 3. Over here, I'm just rewriting my 4 root 3. And then this again, right, root 81 is what? That's a 9. Okay, don't forget that it's multiplying a root 3 though. So there's a root 3 attached to that 9. And then you have your minus 70. Okay, now these are technically like terms, right? You have, okay, you've got 3 of these root 3's. Take away 4 of those root 3's, what am I at? I'm at negative 1 root 3. And then I add 9 of those root 3's on. So I've got 3 minus 4 is minus 1, minus 1 plus 9 is 8. I've got 8 of those root 3's. No different than if I had 3x minus 4x plus 9x. You're technically collecting like terms is what you're doing. Okay, so I think we said we were at 8. Okay, 8 root 3 minus 70 is the final answer for 7a. If we can maybe just do, like, I won't do them all here, but if I did, I don't know, I'm just looking at maybe 7D. Okay, let's take a look at D. You have 5 root 2 multiplied by 11 plus 2 root 2, close bracket, minus I've got a 4 and multiplying an 8 plus 3 root 2. Okay, so remember, numbers inside of roots multiply together and numbers outside of roots multiply together. That's the deal for these, okay? So when I expand here, that 11 is not in a root, and neither is that 5. So it's perfectly acceptable to multiply those two numbers. I get a 55 root 2. I then get a what? I get a 5 and 2 can multiply each other to get 10, and root 2 times root 2 is root 4. Is that okay? Those numbers multiply each other, root 4. And then you distribute again, you get a minus 32, and then you get a what here? You get a minus 12 root 2. And now we're going to clean this up. So we've got 55 root 2. We've got, don't forget that basically, root 4 is just a 2, right? So that's just a 2 here. So I can write 10 times 2. I've got my 32 and I got my 12 root 2. All right, so bottom line is I can collect my like terms, right? This and this are like terms that can be collected. So I'm down to 55, take away 12 is what? Is that 43, right? So 43 of those root 2's. And then over here you've got a 20 and a minus 32, which is just a minus 12. Okay, so that completes 7D. Number 8 is it's all that, it's the same type of work, a little application of those same operations in number 8.